Hello everyone, welcome back to my channel Geography with Sumona. I am Sumona. Today we are going to learn about a very important part of our atmosphere, that is the ozonosphere or the ozone layer. We know that the sun gives us light and heat, which are essential for life. But sunlight also contains ultraviolet radiation or UV radiation, which can be harmful to living organisms. So the question is, who protect us from these harmful rays? Obviously, the answer is the ozone layer. In today's video, we will understand what ozone is, where is the ozone layer located, how ozone is formed, how human activities damage it, and how the world came together to protect it. So, let's begin today's class. Let's start with a very simple example. Imagine that you are riding a bike and you are wearing a helmet. Why do we wear a helmet? Because a helmet protects your head from injury if something hits you. In a similar way, Earth also has a kind of natural protective shield. But this shield is not made of metal or plastic. It is made mainly of ozone molecule present in the stratosphere. The ozone layer absorbs a large part of the sun's harmful ultraviolet radiation before it reaches Earth's surface. So, just like a helmet protects our head, the ozone layer also helps protect life on Earth. That's why we can call it Earth's natural protective shield. Now we need to understand one very important thing, that is oxygen and ozone are not the same thing. The oxygen that we normally breathe is called O2. It is called O2 because one oxygen molecule contains two oxygen atoms. We need oxygen for respiration. But ozone is O3. That means one ozone molecule contains three oxygen atom. So remember this simple difference. O2 O2 means the oxygen we breathe. O3 means ozone, which forms an important protective layer in the stratosphere. But remember, ozone is not simply good oxygen everywhere. Ozone is very useful high in the stratosphere, while ozone near the ground can be harmful to human health. Now, an important question, where exactly is the ozone layer located? Look carefully at this diagram. Earth's atmosphere has several layers. The layer closest to Earth's surface is the troposphere. This is where we live and where most weather phenomena occur. Above the troposphere is the stratosphere, and this is where most atmospheric ozone is concentrated. The ozone concentration is especially high around 20 to 25 km above Earth's surface, although the ozone layer extends over a broader part of the stratosphere. So, if someone asks you, where is the ozone layer mainly found? Your answer should be in the stratosphere. And remember, the ozone layer is not a solid sheet surrounding Earth. It is a region of the atmosphere where ozone molecules are present in relatively higher concentration. Now comes the interesting part. How is ozone actually formed? The formation of ozone is closely connected with ultraviolet radiation from the sun. Look at the first step. A molecule of oxygen, O2, absorbs high energy ultraviolet radiation. This causes the oxygen molecule to split into two separate oxygen atoms. So we can tell or write O2 equal to O plus O. Now we have three oxygen atoms. In the second step, one of these oxygen atom combines with another oxygen molecule. O2. And what do we get? O3. That means ozone. So, in a very simple way, UV radiation helps break oxygen molecules and the resulting oxygen atom combined with oxygen molecule to form ozone. But the story does not end after ozone is formed. Ozone is continuously being formed and destroyed naturally, and sunlight plays an important role in both processes. Some UV radiation helps produce ozone. At the same time, ozone absorbs UV radiation and can break apart again. So there is a natural cycle, that is formation, then destruction, formation, then destruction. Under natural conditions, this process maintains a kind of balance. Think about a bank account. If money is continuously being deposited and withdrawn at a roughly balanced rate, the amount is relatively stable. Similarly, when ozone formation and destruction are naturally balanced and ozone concentration remains within a relatively stable range, the problem begins when human produced chemicals disturb this natural balance. Now let's understand why the ozone layer is so important. The sun produces different types of ultraviolet radiation, including UVA, UVB and UVC. UVC is the most energetic of this type, while UVB is also particularly important because excessive exposure can cause harm to living organisms. Fortunately, Earth's atmosphere and ozone layer absorb most of the harmful UV radiation. The ozone layer acts like a natural UV filter. Think about sunglasses. When you wear sunglasses, they reduce the amount of harmful or excessive light reaching your eyes. Similarly, the ozone layer reduces the amount of harmful ultraviolet radiation reaching Earth's surface. This protection is extremely important for human health, plants, animal, and ecosystem. Now imagine a world where the protective shield becomes much thinner. Then what could happen? First, human health could be affected. Excessive UV exposure can increase the risk of skin cancer, eye damage such as cataract and other health problems. Second, it can affect plant and crops. Plants need sunlight for photosynthesis, but excessive UV radiation can damage sensitive plants and affect their growth. Third, marine ecosystem can also be affected. Tiny organisms such as phytoplanktons are important, the base of many marine food webs. Increased UV exposure can harm these organisms. Finally, excessive UV radiation can damage some materials, causing them to deteriorate faster. So the ozone layer helps protect the entire ecosystem. Now we come to one of the most important parts of today's topic, that is what causes serious damage to the ozone layer. One major group of chemical was CFC or chlorofluorocarbon. CFC were widely used in the past in things such as refrigerator and air conditioning systems and some aerosol application. When CFC reaches the upper atmosphere, ultraviolet radiation could break them apart and release chlorine atoms. These chlorine atoms could participate in chemical reaction that destroy ozone. So remember, CFC release chlorine in the stratosphere, then chlorine participates in ozone destroying reaction. Now let's understand why chlorine was such a serious problem. A single chlorine atom can participate in a chain reaction. In simple terms, Chlorine reacts with ozone and helps convert ozone into ordinary oxygen. The chlorine atom can be regenerated during the process, allowing it to participate in the destruction of many ozone molecules. Under favorable condition, one chlorine atom can contribute to the destruction of many thousands of ozone molecules, and historical estimates have sometimes reached around around 1 lakh. The important idea is one chlorine atom can act repeatedly. That's why even a relatively small amount of chlorine in the stratosphere can have large effect on ozone. One of the most famous examples of ozone depletion occurs over Antarctica. Scientists observed a severe seasonal thinning of the ozone layer over Antarctica, commonly called the Antarctic ozone hole. But remember, ozone hole does not mean that there is literally an energy hole in the atmosphere. It means that the concentration of ozone becomes very low over a large region. This happens mainly during the Antarctic spring, particularly around September to November months. Very cold conditions in the Antarctic stratosphere help form special cloud chemical reaction. On these clouds make chlorine compounds more reactive. When sunlight returns in spring, this reaction contributes to rapid ozone destruction. Now here comes one of the most important positive parts of our story, that is, scientists discovered the dangers. Countries recognized the problem and the world decided to take action. In 1987, countries adopted an international agreement called the Montreal Protocol. So, Montreal Protocol is always related to ozone gas. Its main goal was to phase out the production and consumption of many ozone depleting substances. After the Montreal Protocol and later amendment, production and consumption of ozone depleting substances declined greatly. This is an excellent example of how science, international cooperation, and environmental policy can work together. And now we have some good news. The ozone layer is showing signs of recovery because the use of many ozone depleting substances has been greatly reduced. First, ozone concentration declined. Then after action was taken, the trend began to improve. But the ozone layer does not recover overnight. Many ozone depleting substances remain in the atmosphere for a long time. So, recovery takes decades. Scientists expect the ozone layer to continue recovery during the coming decades if current protection remain in place. This gives us an important lesson. Environmental damage can take a long time to repair, but strong and sustained action can make a real difference. So, what can we do to protect this progress? There are three simple ideas shown on the slide. First, maintain air conditioning and refrigeration equipment properly. Well-maintained equipment is less likely to leak refrigerators. Second, dispose of old equipment properly. Old refrigerators and air conditioner may contain refrigerators that should not simply be released into the atmosphere. Third, spread awareness. Knowledge is also a form of environment protection. Protecting the ozone layer is not only the responsibility of scientists or government, all of us have a role to play. So, let's quickly revise that what we learned today. Ozone is O3. The ozone layer is mainly found in stratosphere. It absorbs much of the sun's harmful ultraviolet radiation. Certain chemicals, especially chlorofluorocarbon or CFC and other ozone depleting substances, damage the ozone layer. The Antarctic ozone hole became one of the clearest example of this problem. In 1987, the world came together through the Montreal Protocol to reduce ozone depleting substance, and today we have encouraging evidence that the ozone layer is recovering. So, the story of the ozone layer teaches us some very important lesson. When science identifies a problem and the world works together, positive environmental change is possible. I hope this video helped you understand the ozone layer in a simple and interesting way. If you found this video useful, please like, share and subscribe to Geography with Sumona. Thank you for watching.